We may use a mix of languages across both of those. We may use Java and XML in our app, maybe even some JavaScript. We may use Groovy and Java in our build tools with Gradle. And this sort of context switching can slow us down, and it can inhibit a lot of new developers coming to our code base as well. I'm Ty, and I'm an Android developer at Uber. I've been working on our external developer platform for a little while. And today I'm going to walk you through this fun new programming language that probably a lot of you have heard of by now, called Kotlin, and how it can help make your life a little bit better, both in the app as well as in Gradle. And we'll be covering a lot of the Gradle stuff today, specifically. Before we begin, why isn't Java good enough? Why am I up here talking about Kotlin? Well, one of the major talking points about Java recently is on Android is Java 8 support. And when we'll get that and what it looks like. And we do have that to some degree, you know, with Jack, and Jack is now deprecated, and we have retro lambda. And we have a few ways of getting some of the Java 8 stuff in our Android apps today. But you know, a lot of those people just think about with Lambda support. But what if you wanted to use the stream APIs or the new time util APIs that are in Java 8? Well, you'd have to use some backport libraries, and it becomes kind of a headache. There's some libraries that'll help you, but in the end, you have Java 8 support on Nougat and above, and then you have Java 7 support on a handful of Android versions, and then on some of the older versions that are still in the wild that we need to be supporting is still Java 6 support. So it makes it really difficult for us to understand what we can be using and where. Java on Android can also be quite error-prone. Capturing inner classes, for example, leaves your app prone to memory leaks. And especially when we're using asynchronous operations with activity contexts and things like that. And then there's the general language restrictions of Java. Besides some of the syntactic things and the libraries that I mentioned, there's also the systematic problems, like the verboseness of it, which inhibits new developers, nullability, which can often cause crashes, and mutability, which often leads to poor programming decisions. I think these syntactical problems can be resolved with a lot of great libraries, like I mentioned, but using some of the other more widely known problems like the verboseness and the nullability are a little more systematic and a bit more of an issue, and I think Kotlin can help us with those. But what about Groovy, you say? You know, Groovy is the default language in Gradle. And it's a useful language, however. But I think it has a few limitations that make it less than ideal as well. First is that it's a dynamic language. And Kotlin is statically typed. So Kotlin's going to spend more time processing the language runtime, trying to resolve runtime checking, whereas Kotlin has been shown to speed up even Gradle configuration steps when it's used in the build tool. And because Groovy is dynamic, it's harder for your IDEs to infer what should be happening, especially when you want to know that an error is going to happen with the script that you wrote, or you want something to autocomplete. How many of you have been working in just your regular build.gradle and had frustration that you couldn't autocomplete a common method name that was used? Okay. With the statically typed language, though, the IDE can be a lot smarter. It can give you that feedback sooner. Groovy also brings a number of performance and memory concerns if it was going to be used in Android directly. The standard runtime itself is quite large, so you'd have to bundle that with your Android app, and that would increase the binary size significantly. The dynamic nature means that the garbage collector on Android would be a lot more active, and it would be more prone to causing jank and frame skipping in UI. So I believe Kotlin can deliver on some of these concerns that we have both with Java and with Groovy out of the box. So with all its hype, I'm sure you've heard a thing or two about Kotlin. For those of you who haven't or aren't super familiar, I'll dive into the language a little bit, some specific advantages that I think it has. Well, first, it's built by JetBrains, the team behind Android Studio and IntelliJ. And it's completely built in the it's open source. The language has been in active development for about 5 years. And Android developers are one of its largest target audiences. It's built with mobile in mind. There's already many top apps that are using Kotlin in production. Both Square and Pinterest have Kotlin code that's out available for you. There's many more apps that are working with Kotlin, as well as using it in build tools and testing. Since the first time I gave this talk, Gradle has officially announced Kotlin support as well. And this dedication means that we'll see it as a first-class citizen, we'll see improved development, and it's just going to get better. Because it's designed to work with Android from the beginning, it's fully Java 6 compatible, it kind of resolves that issue I talked about where we have multiple versions of Android that are out in the wild. And it's 100% interoperable with Java, so you don't have to make the decision to fully convert your project over to Kotlin if you want to use it. You can start using it in small pieces today. The language itself has a standard library that's very small. It's bundled. It does have to be bundled with your application, but it comes out to about 600K. Now, to contrast that, if any of you have done iOS development and you want to use Swift, you have to bundle Swift with your iOS app. And today, that's about 9 megabytes in size. So when you're talking about emerging markets where people have less bandwidth, slower networks to download your apps, download updates, that becomes really problematic. Because Kotlin is statically typed, it doesn't have the same runtime overhead and it keeps memory allocation in mind as well. This could be a large constraint on Android where the GC does cause a negative user interaction, but it's not as problematic with Kotlin as it would be in something dynamic like Ruby. And lastly, Kotlin is a modern language. A lot of people complain about Java that it just feels old and antiquated. It has many awesome features that make development fun. And you can use it on all of your Android devices today. But more importantly, Kotlin can help us with many of the constraints that Java and Android both introduce. By using Kotlin's type-safe system for null safety, it can help reduce easy-to-avoid null pointer exception issues and avoid nasty states that we may get into. And it helps us reduce the boilerplate that's very common with Java, making our code much more maintainable. The Android API also relies primarily on an architecture of inheritance, and while this works well for them, it often puts the burden on the app developer when you're wanting to try to create an architecture of composition. There are also many APIs that require a lot of ceremony to use. You have to do things in the right order or else they don't work. Just think about the steps required for toasting, saving SQLite transactions, or starting the media recorder. And lastly, while Java is too verbose to define a maintainable and expressive build script, I believe that Kotlin is expressive and concise enough to meet those requirements, and it competes with many aspects of Groovy, the preferred build language of Gradle today, while providing much needed type safety to reduce errors and expedite development, especially for new developers coming to the code base. So, what do we have with Kotlin? What kind of new features does it introduce? Well, we have higher order functions and properties and mixins, and I think I'm only supposed to be up here for another 40 or so minutes, so maybe we'll just talk about a few that I think will be more useful to you guys today, especially in dealing with Gradle specifically. One of the most common exceptions in Java development in general, Android or not, are null pointer exceptions, infamously known as the billion-dollar mistake. And unfortunately, Java doesn't have a first-class representation of something that may or may not be null. If you're using Guava, you may have optionals, but it's not built into the language. By having a runtime-based check for null, it makes the code much more susceptible even when null checks are being utilized. Having a potential value of null requires defensive programming, which leads to less maintainable code. Here's our first example, Kotlin's variable assignments. You'll notice Kotlin uses a syntax where it reverses the type and the name ordering for variable declaration. And in this case, we'll get a compile time exception on the second line that we have defined here, as we are not allowed to assign null to the var a that we have here. However, in this next example, you'll note the question mark along with the declaration. Now, this indicates to Kotlin that the value may be null, and we'll take care of checking that. But once we try to utilize the variable here, we'll see a compilation error as well, as we need to explicitly check for null before using. If this was something in Java, you would notice this would have to be a runtime failure. We get the advantage of a compile time check here. You may also notice the two different ways of declaring a variable that I've used. both var and val. Kotlin uses var to indicate something that's a mutable variable, and it indicates val to indicate an immutable value. In this next example of nullability, we can use a few different formats to check for null. In this first line of code that I have here, you'll note the question mark in use again. When that's declared, any further method calls on that object will return null if the parent object is null. And that removes the need to do this nested if null checking all the way down as you want to dig in on an object and all of the fields that it may have. In the second line of code, we use a slightly different format. Instead of utilizing null, we specify a default value using a single expression if else. And in this last example, we take advantage of the elvis operator to simplify the syntax of the second example that I have on the slide. Let's move on to another cool feature of Kotlin, which is class properties. In this example, we'll define a class called user and specify a member variable for the name. Using the syntax where we put the member in line with the class name is one approach. Although we could specify it below in the class implementation as well, which might be a little more familiar. Although this looks like standard Java field, this is a synthetic property. That means that the getters and setters are automatically generated for us, and that's what's being used near the bottom of this slide. That reduces some of the boilerplate that we see. We can, however, override the default generated getters and setters to provide our own custom logic if we need to, by declaring a get and set method below the property. You'll notice that we changed the syntax for the property declaration from the previous slide as well, just to show another way of that being done in Kotlin. In addition to using properties to clean up boilerplate code, Kotlin offers a concept called a data class. This is designed to be a lightweight POJO and do all the things that those classes normally need to do. But by adding the data keyword to this declaration, we'll get the behavior automatically. It automatically generates an equals and a hashcode method for us, so we don't have to implement that ourselves. It also generates the toString method for all of the fields and the constructor parameters. Lastly, it'll generate the copy methods with default parameters, so that you don't have to implement builders to copy and paste and copy and create these immutable POJOs as you move around your code. Data classes have many limitations as well, though. For example, they cannot extend another class, and they cannot be abstract. So I would recommend looking up the restrictions to see if this is right for you in your current implementations. Let's move on to another example. Function literals, or lambdas, commonly known, are a great way to make code more readable and have come to be expected from a lot of other modern languages. Java 6 doesn't have support for these. But using a language like retrolambda that rewrites the bytecode from lambdas to single abstract methods is a great way to backport that functionality. Lucky for us, we get this out of the box with Kotlin. And in this example, we'll see a few different syntactical ways to write them. They will infer the type from the definition, so that we can reference the variables directly in the first example. In the second, with only a single parameter, we can refer to it as the standard int notation. Similar to Groovy, we can store the function literal in variables and then use them when they're needed later on. Expanding on the function literal concept, Kotlin also provides us with higher order functions, or functions that take functions as parameters or return them. Now, this is a very powerful technique in Kotlin to write very clean and readable code. And we'll get to some more powerful examples of using this with real-world use cases for cleaning up both Android and Gradle here in a little bit. But we need to understand one more concept before we start walking through those. That last concept that I want to talk to you about is extension functions. Now, Kotlin gives you the ability to add methods to existing types or classes. And this is very powerful and similar to many other languages where you may have seen this, like C#. Now, this is a great way to replace the utility hell that Java becomes when you have a util class that represents interactions with an object that's out of your control, perhaps in a library or in the Android framework itself. Now, this syntax requires that you just define the type dot method name, and then the code interacts with that class as if it was owned by that class. It's in the same scope. Now, please note that you cannot override existing methods on a class using these. This is only for defining new methods on those classes. Another thing to note is that Kotlin gives you a method in a class where you've defined the function extension only. So if you wanted to use that in another class, you would need to explicitly import it from other classes where you had defined it. And that's different than C#, for example, where if you define it once, you get access to that everywhere in your code base. I mentioned earlier that extension functions were a great way to avoid that util hell, but I also mentioned that Kotlin is fully interoperable with Java. So what are these actually doing, and what's this magic going on behind the scene? How would we use those from Java as well? It's generating a class with a static method that intercepts all the calls to the object in Java, the object in Kotlin, but in Java you can call that generated static util directly. Kotlin will assign a default name to the file based on the file name. But you can specify something custom if you want by using the @file::jvm name annotation here. Now, if you wanted to group methods from multiple classes into one generic util class to access when you're using the Java part of your code base, you could also do that as well using this other annotation that we have here with the multi-file class. This can be really powerful in Android to clean up the APIs that exist. Here's the traditional way of saving an object into shared preferences. You can see that it requires us to init the preference editor first. Then we put our object into the preference editor, and then we have to call apply. And this is prone to error because it requires the ceremony to be followed exactly. And if it's not, we may end up forgetting to save our value. So how can we make this better with Kotlin? Here's the same functionality, but using the last three concepts that we talked about in Kotlin: extension functions, higher order functions, and function literals. We add a method edit to the shared preference object that takes a function literal that's defined as another extension function of the editor class. Now, that can be a little confusing at first, but it's incredibly powerful. And it allows any function literal passed in to act as if it was a method on the shared preference editor object. This allows us to use the code in a very type-safe way, knowing that we don't really have to worry about if the data was saved appropriately because of the platform-esque implementation that we have here. We know that we're saving it in the correct editor object. Now, a caveat to note is that since Kotlin is Java 6 compatible, and we're using these higher order functions, they impose certain runtime limitations. Each function is an object, and it captures a closure. And these variables are accessed in the body of the function. So now we have memory allocations, both for the function objects and the classes. And these virtual calls introduce runtime overhead as well. By adding the inline keyword to the function, though, we're telling Kotlin compiler to compile the code inline, as opposed to a bunch of anonymous inner classes. So it's as if we had written the very first Java version here to the machine, but we get the clean API from Kotlin here. Now, the first version is more error-prone, but to the machine it's much more readable. But now our bytecode between Kotlin and Java is the same, and you remember when I said that Kotlin doesn't really add any runtime overhead? This is one of those features that allows for that, although it has to be explicitly understood. These Kotlin features give us a powerful ability to start creating a DSL. There's this proof of concept library built by JetBrains called Anko, which is designed to allow you to replace the standard Android layouts in XML with this expressive syntax. Now, you may also notice that the syntax is starting to look quite similar to Groovy. So I'm showing you this example so we can start to understand how Kotlin gives us the similar DSL ability. So maybe by now I've sold you on some interesting reasons that you might want to use Kotlin in Android. But introducing that would further add fragmentation to your entire code base. You may have Kotlin in your app as well as Java still in your build tool, or you might have XML, you might have JavaScript. In your build tool, you may have Groovy and some Java written for the plugins. That's a lot of languages to start thinking about. So, because we're not great at context switching as humans, and it's gonna reduce our developer productivity, maybe we can take Kotlin to the next level by starting to introduce it into the build system as well and reduce some of that fragmentation. I'll walk through a common example that many of us have used, and that's how to load an API key from a configuration file, maybe to use a web service or an SDK. And we'll do that in Gradle through some tasks and then a Gradle plugin, and then we'll do that in Groovy and Java first, and then we'll move to show how that can be done in Kotlin to reduce that fragmentation. Of course, we first need to install Kotlin in our project. And using Gradle, it's very simple. We just add a build time dependency. And we apply the plugin. We can then intermix the .kt files and the Java files in our project for Android, or even Groovy for the Gradle plugins. Be sure to install the IntelliJ Kotlin plugin or in IntelliJ or Android Studio. It can help facilitate adding these dependencies, as well as it adds a converter for you to automatically convert Java into Kotlin files. Now, it may not be the most idiomatic Kotlin, but it's a great way to get started. This gets Kotlin in our runtime code, but let's take a moment to make our build script better with Kotlin too. The Kotlin support in Gradle scripts is still a work in progress at the moment. It was announced last year at Gradle Summit, and around the same time, I worked on an open source project with the Gradle team to bring some example support to Android as well. Now, if we do this in Gradle, the scripts become a little more readable. It looks a lot like Groovy, but at this point, the integration is somewhat limited and it requires some workarounds. Here's this example that I created as a simple hello world for Android. I'll link this when the slides get published so you can see the official Gradle repo as well. And it adds Kotlin support to an Android project for the build script. However, if you look carefully at the previous example, you'll notice a few lines that didn't look quite right if you're used to looking at your build scripts in Groovy. That's because to make Kotlin work in a similar idiomatic way to what Android developers are used to already with Groovy, I had to add a lot of extension functions to clean up the API and create a more fluent interface. Some things that we did here. We created a block for the Android tag. We needed named access for the release build type, so we had to use find by name to look up the release. We also needed to directly access the default product flavor. And that default config on the default product flavor isn't immediately available because it's on a subclass of the parent class, so we had to explicitly call that out here in the function extension. Now, these aren't the most approachable. However, I think it shows the direction that this is going, and with the Gradle team working on the first class support of Kotlin and Gradle, I think a lot of this will be cleaned up, and as they're working with the Android tools team, a lot of this will be internalized, so we won't have to be dealing with some of this stuff. This is a proof of concept, but I think it just shows maybe the future of what we have here. Here's a common scenario that a lot of the developers in the room would be familiar with. You want to sign an outgoing request to an API with a consumer key, or a secret, for authentication to your backend. But in this example, we define the key and secret, and then we use them with some generic SDK or library that you may have defined. Let's focus on that API key part specifically. One obvious improvement that we can do here to productionize this code is to have different keys for different build types or flavors. Maybe you have staging and production, maybe you want to use analytics on one but not the other. Maybe you just don't want to share the same ones during the development and QA cycle. More interestingly, what if you wanted to push your code to an open source repo and you didn't want to expose the keys? Or if you wanted to allow contractors or third-party developers to work on this and you didn't want to expose the production keys there. Ideally, we have a proper separation of concerns to remove this from the code base and give confidence to the developers whenever they're pushing this code somewhere that they're not exposing sensitive information. This is an example of where Gradle can really shine today as build tooling. What we have here is the Android Gradle plugin DSL that allows us to add a constant to the generated build config class that's accessible at compile and runtime for Android. We're able to define different keys and secrets based on the flavors or build types here. And then we can access those. And the syntax is very straightforward. We just declare the type followed by the name and the value to be accessed, and then that's all created as generated code in Android. So now we have keys provided to Gradle that's more broadly accessible in our Android source. A good first step. And it allows us to provide different keys for different build types, meeting the first requirement that we talked about. But we still haven't been able to achieve our other goal of separating the API key from the main repository. It's still listed in the same repo. So let's look at other techniques that can help us meet those new requirements as well. Gradle provides a number of mechanisms to provide or inject values into the build while it's running. There's the Gradle properties, or also sometimes referred to as the project properties, or the -p parameter when you're running it from the command line. This lives in various locations, starting in the local project defined as the Gradle.properties file. Or if you want to override and keep it out of your repo, you can put it in your user's home directory under user home /.gradle/Gradle.properties. And that lives outside the repo. And then there's also the standard system variables that you can access from the running terminal or the -d to override those from the command line. And lastly, you can load your own custom properties files directly from disk and then use the values in the rest of your build lifecycle. In practice, the choice varies from team to team and is largely driven by your team's policies and processes and structure. What CI systems do you use? What your onboarding process looks like for new developers, and other minor constraints. Once we have the property accessible in our build, this get prop function uses both the Gradle properties and the system variables to set the order of precedences on how it resolves them. So you can have your development key for your development team while they're working on this in the local machine, and then when it comes to the CI build, the system variable is set by a build engineer or by DevOps, and it lives on the CI machine, and it avoids the accidental check-ins of the production keys. And this could exist to protect some of the confidential information of your org. And here's how that can be used in the that get prop method can be used in your build.gradle. Whatever that's been set to, we'll inject that into the build config class file. And we have the capability to meet both of our requirements that I described earlier. But if you have multiple keys, it can be tedious to keep track of all the different environment variables required to set up new development environments or new CI boxes. You might want to create a custom properties file as an example, leaving the .gradle properties, the Gradle.properties file checked in for insensitive information like your Maven artifact ID, version number, group, something like that. But then you may need a file that uses Java-based SDK or a library that requires runtime access to a specific set of information at runtime. Or to simply onboard a new engineer with some of that more sensitive information. It would be good if we could generate the file that has this information, then we add it to the .getignore so that it's not part of the code base when it's checked in. So let's create a custom task defined in the build.gradle, and we'll get the values that we need and then write them into the file for our build. If you're a Java engineer that's not very familiar with Groovy, with output stream will be of interest to you here. It's an extension to the file class implemented by Groovy that wraps opening a file and reading output stream. Conceptually, it's very similar to Kotlin's function extensions that we talked about earlier. Groovy, like Kotlin, doesn't have checked exceptions, so there's no need for a try-catch here. So now, all you need to do is run this task once for whenever you have a new environment, a new developer, or additional keys. And if you add a custom properties file to the .getignore file, then you can push the code to a public repository without worrying about the sensitive information that may be contained in there. But your team might have more than one app. And for consistency, you want to make sure that every app is set up and configured in a similar way. So, even better than this specific task, maybe we want to share this process or reuse this process for the other apps in your org. So let's make this more consistent for all your apps by defining a Gradle plugin that can be shared. Now, the Gradle plugin has three basic ingredients. The first is the task. And it's typically used to represent an action that's triggered from either the command line or another dependent task that you have defined in your build script. You can also extend the project object for various things. Some examples are providing values from the build.gradle to a function or another plugin. This is the Lambda object that you normally see in the DSL for your build.gradle files directly. Lastly, the plugin itself, the implementation, it can be used to bind the previous two components into the Gradle lifecycle. And this is really the business logic that we're going to be talking about more today. A very simple way to create a custom task is by extending the default task class that exists in Gradle. Functions annotated with the @task annotation will be called when the task is executed automatically. Create file function here contains the logic that we wrote when we needed to write the values into the custom property files. And we have added some generalization here to allow for a little bit of reusability. This task requires keys and output file to be provided so that each plugin consumer can supply their list of keys and the path to the file that they want to write these to. Because this code will sit outside of the main build.gradle, we could have written it in Java as well. It doesn't have to be in Groovy for this example. So let's go over a simple example of why I think either Groovy or Kotlin at least is more preferable than Java, than even the Groovy version. It has a lot more boilerplate. It has null checks, it has try-catch statements. It just incredibly enhanced the verbosity of what was needed here. And it actively discourages many new developers when they look at something like this. I'll do a quick poll. How many of you have opened up an Objective-C file in the past and had a hard time looking past all of the brackets? It looks very confusing. That's how a lot of non-Java developers feel when they open up a Java file. It just feels incredibly verbose and overwhelming. So we want to reduce that barrier to entry so that it's accessible to more people. For dramatic effect, I'll show you what that same code looks like in Java if we commented out all the ceremonial and boilerplate code. You can see that it's a lot more concise and easier to follow along. It's also starting to look a lot like the Groovy example, just functional. So now that we've gone down this small rabbit hole, let's go back to building our plugin. To continue along with the task, another important part is the defined inputs and outputs to that task. Input is the Gradle annotation that marks a field to be an input task to be completed. And an output file is another Gradle annotation that declares it's an output of the task and that it is a file. And this is really important and of particular interest to speed up your builds, because when you use the Gradle clean task, it's going to be removing these. So if you want to have proper caching, you need to appropriately use the output file here. To make it easier for our plugin consumers to configure the task, we'll provide an extension. An extension is a simple class that allows the plugin consumer to provide certain data to run our plugin. It uses the Gradle plugin DSL to do that. Here's an example of a pogo, or a Groovy version of a pojo, plain old Java object, that gives us this functionality. Note that these data members at compile time will be provided with a getter and setter automatically. And this is very similar to the synthetic properties that we talked about a little bit earlier in Kotlin. To make it more idiomatic, we'll also provide the key file to shortcut the assignment to file in Groovy. You can also add the getProp function here in the extension so that the function can be available to any project that applies our plugin. And lastly, the plugin itself. It'll help us to bind and integrate those other two components into the Gradle build lifecycle. First, we want to add our extension into the project object by using the extensions property. This allows us to access and provide the data by the plugin consumer, and it allows them to use this syntax in their build. The plugin class interacts a lot with the project object, and Gradle provides a configure function for the project object to allow more concise syntax that infers the project object that will be used with the following closure. You can see on the second line, project extensions here. It's a more concise example, and it can be inferred as simply extensions with the configure closure with Groovy and Gradle. And it performs much like the first example. Another important part of the plugin is to make the task available to the project so that its scope is available. The after evaluate closure, if you're not familiar with Gradle, means that you want this block of code to be run after all of the initialization phase of Gradle has been completed. Let's say we only want to add the task if the keys have already been assigned. That is, we do this in the after evaluate closure to allow the plugin consumers to set it into build.gradle. Here, we can see how one would use the plugin in your build.gradle script that we had just written. So there you have it, our Gradle plugin, written in Groovy, simplifying your use of web API keys against your SDKs or APIs that you need to hit on your web service. Now, let's see what this example looks like in Kotlin. Here's the syntax that you should be somewhat familiar with from the earlier introduction I gave to the language. We have two fields: keys that are a list and file that is a nullable. Now, we don't need it to be nullable specifically, but in this demo, I want to make it nullable to show how you use Kotlin to deal with Java APIs that are nullable by nature in Kotlin. Please pay attention to the first line that we have defined here, the open on the class definition. Because in Kotlin, all classes by default are finite. And Gradle, creating this task, needs to proxy the task and create a subclass of it. So if you didn't add the open here, you would get an exception when you started to run your build, as Gradle tried to subclass this. Here's a version of the create file function translated line by line, similar to Groovy. Kotlin doesn't have checked exceptions either, so any uncaught exceptions will just be elevated to the caller here, so we don't need to have that verbosity that we saw in the Java project. Here we have another version that's a bit more idiomatic to Kotlin. We've removed the for loop and replaced it with a for each, and a function literal with that. Now, what's more interesting here is this last line using the double bang operator. The double bang operator indicates that we know that this may be null, and if it is null, to actually throw a null pointer exception up to the caller. This is one way to deal with Java APIs where they're nullable by default. Here's our version of that Pojo as a Gradle extension. It uses the data class from Kotlin that we talked about earlier. And now we're looking at the plugin class. Similar to what we did before, we add the extension to the project. And again, we want to use the after evaluate method here to allow the extension to be set in the build.gradle. While this is cleaner than the Java example I showed, at this stage it still looks quite verbose to me, and I'd love to further improve on that. So what can we do to clean this up a little bit more? By utilizing a couple of function extensions, we can assign the configure function to the project in the first line. The extensions on the second line would make this code a lot cleaner as well. And it would be a lot more comfortable and concise to those of you coming from Groovy who are used to writing your build scripts that way. So here's the example of how it looks like before and after we use the extension functions to clean it up a bit. You can see in the second example how we move towards a more declarative and a Groovy-like syntax. So now we have the final version of our plugin in Kotlin. Just like with the Groovy version, we add the extension. And after the evaluation is done, we create a task to create the file based on the extension data. It's declarative, it's concise, and it's familiar to Groovy developers, but it's consistent with the Kotlin that's potentially already in your Android app. And if you're using Anko or similar patterns in your Android app, all your code can start to look quite similar. You have a lot of reusability between the different layers of your stack. You can even use Kotlin to start to compile the JavaScript if you have JavaScript in your application as well. I believe this starts to reduce the context switching a lot, and this required more overhead to get up and running than you might have expected. It's not completely drop-in. But as you start to understand that, I believe that improving the barrier to entry for new engineers and improving the consistency of shareable code outweighs a little bit of the extra overhead that we needed to do with the function extensions. And I think that as this continues forward, as Gradle adds more first-class support for Kotlin, as the community builds upon this, a lot of this will be abstracted into libraries and the platform itself. So we've talked about a lot of resources here. We've talked about a lot of info here today. And there's a lot of great resources on the web to help you dig deeper into Kotlin. The community is really excited, it's really fast moving, there's a lot of new projects that are coming in. If you want to get started today, the docs are a great learning resource to start. These are all links, so when I publish the slides after, you can dig into this. If not, just searching for Kotlin docs is going to take you to the right page onto kotlinlang.org. The Kotlin Koans are another project built by JetBrains, and it's a way to play with Kotlin in your browser in kind of an interactive IDE. They have a lot of little puzzles to play with, and you can kind of get a feel for the language right away. It's pretty cool. Anko's this proof of concept plugin that we talked a little bit about today. Seems like it is being actively developed, but at this point, I don't know that I would explicitly recommend using it over XML layouts, but I can see where that cleans it up a lot and going forward where it may get to that point. It's also a great way to just understand the implementation of these DSLs by digging into the source. It's open source on GitHub and linked from JetBrains' Kotlin site. The official Gradle repo owned by the Gradle org also has the Kotlin examples. This is where the Hello Android example lives that uses the Kotlin in the build script. You can dig in there, see some of those function extensions, clone that down to your local computer and play with that. It was a great talk that Jake Wharton gave last year. It was a deeper dive in using Kotlin to improve Android development specifically. I believe that was given at OrDev. The slides and the video are available if you Google that or click this link once these are published. Lastly, the code we've been going over today exists in an open source repo. This was a project that I worked on with a coworker, and this is available. So if you want to dig in and play with your own Gradle plugin that's written in Kotlin, you can see different branches where it exists in Groovy and Kotlin, so you can compare against the two. I believe the more people that use Kotlin, the faster we can all have a modern language in our day jobs. Since Google may take a while to sanction Kotlin on Android, if they ever do, they kind of have this view of just kind of let the community build. I think it's up to us to drive a lot of these best practices forward. While Google owns Android, the platform, it's an open source ecosystem, and we're all responsible for making it a better and more inclusive environment for everyone. I have a few minutes now, so I can take some questions. If you don't have any questions now, I'll be around. You can come grab me after, and we can talk about Kotlin and Gradle, or if you had questions from my talk yesterday, I'd be happy to talk about building developer platforms as well. Thanks, everyone.